Method of sections is a powerful tool to determine forces in statistically determinate plane trusses. Consider this problem. If you want to determine load in blue member using method of joints, you have to proceed in following manner, from one joint to another joint. In short, you have to analyze 5 joints to determine force in the member. So you have to solve for 10 equations. But using method of sections, just by solving 3 equations, we can solve for load in any truss member. That's the power of method of sections. Steps involved in method of sections are as follows. First step, determination of reaction forces. We can use 3 equilibrium equations of truss to find this. But for cantilever truss, you can skip this step. Now for the most important step, cutting the entire truss into 2 parts by a section line. We'll learn how to draw a section line in coming sections. Third step is to apply concept of equilibrium to any of the cut part so that we can determine the member forces. The big question: how to draw a section line. Section line should pass through the members, whose internal force has to be determined. Section line should not cut more than 3 truss members. This is because we got only 3 equilibrium equations, so we can solve only 3 unknown forces. Let's see a few examples for drawing section lines. For this case, if you want to determine force in member 1, we can draw the section line like this. This line is passing through only 3 members, so this line is good. If you want to determine force in member 2, we can draw section line like this. Here again, the line is cutting only 3 members, so we can solve for the unknown forces. In this cantilever example, for determining force in member 1, draw the section line like this. Now to find out internal unknown forces, you can separate out sections. Section at right-hand side does not have a support, so if I apply concept for equilibrium to that section, we need not solve for reaction forces. Assume all 3 internal forces are tensile in nature. Since this section is under equilibrium, we can say sum of horizontal forces is 0, sum of vertical forces is 0, and moment produced by truss forces at any point is 0. Using these equations, we can solve for 3 unknown forces. It's interesting to see that in method of section, we can completely omit effective forces in uncut members. While solving, if you get sign of any force as negative, that means member is under compression. Now let's consider the previous example. The first step, determination of reaction forces, from free body diagram. This section is good. It has got only 3 unknown forces. Remaining procedure is same as the previous problem.